I can't move. Why can't I move?
Hello, your motor is disconnected.
What are you talking about?
Your motor, duh!
What does a motor have to do with me moving?
Everything. You can't move without a DC motor and a battery source. You're a BristleBot. Laters!
What is a DC motor anyways? Huh, kids.
Welcome to another episode of Maker STEAM Lab. In this episode, we'll learn about a DC motor. Have you ever used an electric toothbrush and wondered how does it work? What about the spinning blades in a blender? What is the force that makes these and other machines go? The short answer is a DC motor. But to fully understand, we'll need to learn what electricity is and how it can operate a DC motor. Electricity is the flow of an atom's electrical charge. A charge is a property of matter that can be either positive or negative. A typical atom will consist of three main particles: protons, which emit a positive charge; neutrons, which emit no charge or are considered neutral; and electrons that emit a negative charge. Charges of the same type will repel or push away from each other, while charges of opposite types are attracted or drawn to each other. This is called an electrostatic force, which is commonly referred to as opposites attract. Freed electrons can create electricity. Electrons on the outermost shell of each atom do not require a lot of force to be moved. These electrons are known as valence electrons. These valence electrons can easily latch onto other atoms nearby and constantly repeat the process of flowing from atom to atom, creating an electric current. Current electricity can power appliances like our computers, TV, and cell phones. In order to flow, the electricity needs a circuit to direct its path. A circuit is a loop that helps the electricity move from a power source, like a battery, through different electrical components by wires or traces and back again to the power source. The loop is unending, which helps keep the flow continuous. If there is any break in the circuit, the electricity stops its flow. For example, when you turn the light on in your room, you are connecting a circuit path for the electricity to power your light bulb. When you turn the light off, the switch temporarily cuts off the path to stop the flow, and the light turns off. Now that we know about circuits, we'll need to learn more about how to control the flow. A current is what controls the amount of electrical charge that is moving through a circuit. Imagine a water hose. When you turn the water on all the way, the force of the water is fast and powerful. Now slowly turn down the water. It gets slower, right? This is what a current does. It controls the flow. Here is another example of electrical current. The figure on the left has a large current, so electrons flow faster. The figure on the right has a small current, so electrons flow slower. Some electronics require alternating current, or AC, like lamps, TVs, and anything you plug directly into a wall socket. The electricity from this type of current will change from positive to negative charges in waves. The other type of current is called direct current, or DC. DC electricity will always travel in one consistent direction and usually comes from batteries. Now that we've learned some basics on electricity, let's look at a DC motor. A DC motor is a type of electromagnetic motor that uses direct current as its power source for electricity, which means that a DC motor will require some type of battery to operate it. This type of motor takes electric energy and converts it into mechanical energy by creating a magnetic force inside the moving part called the rotor. The rotor is able to move on its own due to electromagnetics, which is when particles of metal become magnetized through electronic currents. Just like a regular magnet, the rotor will propel itself away from charges that have the same electrical charge, either positive or negative. The rotor will continue to spin around until it is removed from its power source. So the next time you see an RC car race or brush your teeth, just realize that there are so many different functions occurring at the same time to make their movements possible. Now it's time for us to make a BristleBot. Here are the materials you will need to make your bot. 1 piece of double-sided foam tape, 1 1.5 volt button cell battery, 1 6mm vibration motor, 2 googly eyes of your choice, the head of a toothbrush, 2 pipe cleaners, and hot glue to attach all your materials. Now that our materials are gathered, let's build. First thing we're going to do is test to make sure that our motor and battery are working. To test, take the button cell battery and place it between the blue and the red wires. If the motor starts to vibrate, both the battery and motor are working properly. The rotor of the motor is on the outside, so you will be able to see its spin when it is powered by the battery. Now, we're going to cut off a piece of the double-sided foam tape and place it on the back side of the toothbrush. Be sure to press down firmly so the tape sticks in place. Then, remove the protective backing. Next, attach the vibration motor on top of the double-sided tape towards the back where the handle would have been. Make sure the rotor hangs off the side of the double-sided tape. You do not want it to hit the tape when it spins. Our next step will be placing the battery. First, you want to make sure that your wires are facing towards the front of your toothbrush. Then, take your red wire and carefully place it onto the foam tape. Press it really firmly to stay. Then, take the button battery and place it on top of the exposed wire. Press firmly so the battery does not move. You can test to see if it's working by placing the blue wire on top of the battery. If your motor spins, you have a good connection. With the battery in place, our next step will be to create the legs of our BristleBot. Using pipe cleaners, bend them to fit the shape of your toothbrush head. Go ahead and create some feet or funky shapes. These legs will help control the direction your BristleBot will move once you attach the battery. Once you've finished forming your legs, take one set and hot glue them to the back of your toothbrush head. Make sure the legs do not touch the rotor. With our back legs already set, let's go ahead and place our second pair in the gap between the battery and the vibration motor. Take your hot glue and place it to one side of your toothbrush and glue one side of your legs in place. Make sure the pipe cleaners are not sitting up against the toothbrush. You want to leave a small arch so that once you glue the other side of the leg, the wire can pass underneath the arch and attach to the battery. When both legs are attached, take some time to adjust to make sure that the bristles are touching the table. You don't want them all the way up in the air because it can throw the balance off the BristleBot. Now we're going to add googly eyes. This will give our BristleBot some character. You can add as many or as few as you want, but the fun starts when you attach the motor and see the eyes go crazy. Now that we've completed building our BristleBot, it's time to attach the motor to the battery. Carefully tuck the wire underneath the pipe cleaner and the vibration motor will start to move. Set it down on your table and have hours of fun watching your BristleBot move around the table. As you can see, you can also adjust the legs to change the directions that your BristleBot moves. When you are done, make sure to remove the wire from the battery. We hope you enjoyed watching this month's episode of Maker STEAM Lab. Remember to post pictures of your completed BristleBots, and we'll see you next time. To request a kit, please call or email the Creation Station.